So welcome back to session 2 of day 1. So now we have with us Dr. Siddesh GM sir and Jamuna S. Murthy madam for afternoon session. So Dr. Siddesh GM is going to cover securing generative AI, strategies for protecting against hardware, operating system, software and data level attack. So let me introduce Siddesh sir to you all. Siddesh GM is currently working as professor and head in the Department of Computer Science, Artificial Intelligence and Machine Learning at MS Ramaiah Institute of Technology, Bangalore. He is the recipient of seed money to Young Scientist for Research for the academic year 2014 and 2015 from the Government of Karnataka Vision Group of Science and Technology, that is VGST. He has published a good number of research papers in reputed international conferences and journals. He has authored books on network data analytics, statistical programming in R, Internet of Things with Springer, Oxford University Press, and Senage Publishers, respectively. He has edited research monographs in the areas of cyber physical systems, fog computing, and energy-aware computing, and bioinformatics with CRC Press, IGA Global, and Springer's Publishers, respectively. His main areas of research interest include the Internet of Things, distributed computing, and data analytics. He is a member of IST and IET, etc. So, we welcome you, sir. I request Dr. Harshavardhan, sir, to present a bouquet. Thank you, sir. So, over to Siddesh, sir.
Good afternoon all. Hope I'm audible. Just I think in the morning session you had some brief introduction regarding GenAI. That is what I learned from the madam. So should I introduce you the basic distinction between your AI, ML, deep learning models as well as GenAI. I hope you had some basic introductory aspects of what it is. So this session I'll try to cover the basic agenda of this FDP. That is, let us try to have the relationship between GenAI and how security aspects can be handled in GenAI. Before moving on to the security aspects, let us learn about what is GenAI in depth, a little bit about that, and some hands-on session we have planned along with Jamuna madam after this session. So first half an hour, 1 hour, I'll try to give some introduction to the aspects of this. So then we'll move to hands-on session on this, right? We'll try to generate some synthetic data and we'll see the BERT models and other things in detail. So, yeah, these are all the key objectives of the talk which I'm planning to cover here. So, we try to understand the security risks in GenAI. I hope we understood the advantages till now. There are a lot of risks involved in GenAI. Let us try to throw some light about what were the risks involved. Specifically, the attack happened on hardware. We know that whenever we talk about GenAI, we need some specialized hardware, right? You can't run your models on a traditional CPU, right? You need some specialized hardware. So that is one of the attacking entity in GenAI. So hardware attacks do happen, and operating system on which your GenAI models are working. So attack happen on there. Even there are some softwares do happen. The attack do happen on GenAI softwares. And even models also. We will try to understand about what all the attacks happens in GenAI. We will take some real world case studies and try to understand how the attack has happened with respect to all these hardware, OS, software attack. 1 or 2 case studies I am just trying to cover here. So, and even once we learned about the attacks and case studies, let us try to understand what all the strategies are there to handle these attacks. So, we will learn about some mitigation strategies so to handle those type of attacks. So then I think after this 1 hour we have some practical sessions. We try to learn about GenAI and security aspects. We try to cover this. If it is pretty bit fast or it is bouncing, please let me know. You can reduce the pace. Okay. So let us move. Basically, I'm not talking about what is GenAI. So directly we jump to the AI stack. What is this GenAI stack? Because in the morning session, Madam have already covered about GenAI tech stack we will learn. Yes, sir. Before moving on to that, let us compare between what is this traditional ML and GenAI. I hope morning session you know that, right? So a quick recap. So these are all the phases do happening in your traditional ML model. So you have data pre-processing. I hope we know what is data pre-processing. Right there, we talk about cleansing, preparing the data for analysis. Right, means removing of dirty data, and you check about missing values and other things, right? So that is data pre-processing. The same thing holds good even in GenAI. You have to do it, right? So we need to clean the data and prepare data for analysis before you proceed. So these first step holds good in both in traditional AI as well as in GenAI. So coming to the second phase in traditional ML, you have something called as feature engineering, where you extract some important features from data. You want to predict some share market analysis, or you have to do weather forecasting, something like that. What do you want? Right? That features you are going to extract, because in your data set you may have thousands of millions of attributes. You may not require all those attributes. It's not the attributes you require. So in feature engineering, we try to extract them. But instead of that, we have something called as prompt engineering here. Right? So prompt engineering, or even you may call it as fine tuning, where you design the effective prompts to guide the AI in generating the desired outputs. So this is the two steps where you talk about the distinction between traditional ML or generative AI models. So third phase, you have training and tuning in traditional ML, where you train your model. I think you know about what is data model training. That is happens in our traditional ML. But equivalent to that in GenAI, you have something called as fine-tune LLMs, where you use the foundation or fine-tune language models for content generation. Because whether you are generating a text, image, video, right? So this is the priority here, right? If I try to compare traditional ML as well as GenAI, so first step remains the same thing. Second, feature engineering. Here we talk about prompt engineering. There we talk about training or tuning. Here we talk about the foundation of fine-tuning your LLM models for that content generation. So yes, finally, deployment and monitoring, right? It holds good in both the models, right? Either it is traditional ML or GenAI. We need to do with deployment as well as monitoring phase. So this is the basic distinction between traditional ML or GenAI. I hope this model, by this time you are aware of this. The entire picture of our ML is you have an AI, ML is a subset of that. You have a DL, it's a subset of this, right? And now GenAI is a subset of our DL, right? So this is the hierarchy and the comparison between traditional AI as well as generative AI models. So let us talk about this tech stack. What are the components you encounter in your tech stack? I hope whenever you talk about networking, we talk about OSI stack, right, or ISO stack. So similarly, whenever you talk about GenAI, you have a well-defined tech stack, right? So let us try to understand what are the components or what does it contains. So whenever you talk about GenAI tech stack, you can classify it into 3 models. But you don't have any standardized tech model, or unlike in our networking, you have OSI organization which standardizes it, right? You don't have any standard model, but with literature review or with some research, you can narrow down to these layers into your GenAI tech stack. So you have an application, model, as well as infrastructure, right? So these are all the 3 layers you may classify GenAI tech stack, which guides the choice for efficient development, reducing the cost, and tailored for your specific applications, right? So this is how your GenAI tech stack can involve, and we know about different components like TensorFlow, PyTorch, right? Python, Julia, NumPy, Pandas, right? Where these components can be fit in any of these layers. So yeah, this is the tech stack layered model or architecture model you may see here. So at the top you have the GenAI tech stack users, end users. I think it looks similar to our voice reference model, right? So you can easily map, you can easily understand the significance of this layering model. So you have an end-to-end app layer, right, where it helps the end user facing applications with their proprietary models. So that is one of the very basic models you will encounter in the GenAI tech stack, end-to-end apps. You have something called as some examples like Runway or Midjourney, which helps you to deal with this end-to-end stack. So next you have apps where you have B2B users, you have B2C applications, right, where you design the applications whether for the customers or your business. So that is one more layer in your tech stack. So very importantly, we work here. You work on closed source model and model hubs and closed source foundation models, right? So generally, whenever we talk about GenAI, we work in these layers, right? We don't go with working on apps or end-to-end apps. Those are all the what do you call it? The production people will take care of them, right? Whenever we talk about research perspective, we talk about closed source foundation model. What is this? Closed source foundation model. There are pre-trained models which are having some APIs, right? Very basic example is our GPT-3 from OpenAI, right? They provide you APIs. Using those APIs to build the model, right? So that is closed source foundation model. You have model hubs. You have something called as Hugging Face. You have something called as what is this? Anyone? You have something called as Replica, right? So these are all the two areas where replicate, right? So these are all the two examples where they talk about model hubs. So these are all the platform to share and host your model. You may build your model, you can share your model using the model hub. So this is the difference between model hub as well as closed source foundation model. Similarly, you have something called as open source foundation model. So they are released as a trained weightages. Like you have a stable diffusion is an example where we talk about open source closed models. So this is the basic functionalities you require: closed source foundation models, model hubs, open source foundation models. So at the below you will find infrastructure. You have a cloud platform, you have the computer hub, right? I don't think any explanation is required for this. So cloud platform, you will use the services. You have some examples like CoreWeave, you have GCP, Azure, AWS. So they offer you a lot of cloud-based solutions to build your AI models, right? So at the below you have hardware. So you have NVIDIA GPU cards or Google TPU, right? So Google, they have their own proprietary solution, hardware for the CPU, and you have NVIDIA's GPU cards, right? So that is the hardware you require for computation perspective. So this is the basic layers you will find in GenAI tech stack. Okay. So basically, we do work on closed source foundation model. We work on model hubs, open source foundation models, right? So we work in these layers. Same tech stack when you compare with traditional ML or generative AI. So tech stack in traditional ML, you have Keras, Hano in ML framework, ML APIs like Watson, databases we work on SQL Server, Oracle. When we talk about tech stack for GenAI specifically, you have orchestration solutions like LangChain, LLM models like OpenAI, vector databases like Pinecone, and different solutions you will find, and LLM ops. So these are all the different entities you will find in the traditional ML as well as GenAI. You have a tech stack in traditional ML also, and you have a tech stack in GenAI. Some of the tools or the solutions in each and every model. So this is the comparison with traditional ML as well as GenAI. Okay, so how your GenAI uses the computer hardware? What are the hardware you require? You require CPU, you require GPU, you require something called as TPU, then you have something called as FPGA. Right? So CPU we know that whenever you are working on small models or you are working on smaller data sets, right? Then we go for CPU. Right? Whenever you have a models are pretty bit bigger and you are working on moderate to larger number of data sets like image processing or video processing, we require GPU, graphical processing units, right? So whenever you talk about dense vector processing TensorFlow operations, then you require something called as TPU. TPU is a solution from Google, right? So Google, they have built their own hardware for TensorFlow processing units, right? So specifically for TensorFlow kind of applications, your GenAI require these hardware. You have FPGA. If you have much larger data sets and your applications are highly compute intensive, right? Means whenever you talk about high performance computing, or these applications are called as resource hungry applications, where your applications require huge amount of resources, whether with respect to storage or with respect to computation, you go for FPGA. Some of the examples under CPU, GPU and TPU you may find, right? Under CPU you have a lot of people who are working or they are offering CPU. So these are all the people who are working on CPU and offering the hardware. With respect to GPU, you have NVIDIA, you have AMD, right? I think we know these are all the major players who are offering you GPU, and TPU. You have Google, who has introduced this TPU. Right? These are all the hardware you require. Let us take with respect to this hardware, and let us try to understand what are the case studies. One of the basic example is OpenAI, right? So OpenAI is offering GPT-3. Right, so trained on supercomputers with thousands of GPUs, where you require immense power requirements and hardware accelerators are required. When you go for TPUs, whenever you require accelerators, right? Whenever you need to enhance your processing capacity, then people will go for TPU. So this is one of the very basic case studies where the generative AI is dependent on these hardwares, specialized hardwares, right? So further, like cloud platforms, you require compute on demand, you require scalability and flexibility, then we go for cloud. I hope we know the advantages of cloud. Why we go for cloud? I think because of these two parameters, people go for cloud, right? Whenever you have a requirement of compute on demand, scalability and flexibility, right? Whenever you can't afford the hardware at your place, then you go for cloud, right? The same thing holds good even in GenAI. In GenAI, use compute on demand. Yes, you have AWS offerings, you have GCP, Azure. You have very interesting solution called as CoreView, where they offer you on-demand solutions, right? Whatever the traditional web development we are using in cloud, right, or computation we are using on cloud, the same thing holds even in GenAI also. Yes, we are aware of AWS and GCP. Let me highlight about CoreView. CoreView is one of the specialized cloud provider, especially designed for AI workloads. To deal with AI workloads, so cloud we offering you something called as containers, CPU compute, you have virtual servers, GPU compute is offered by them. So this basically designed for GenAI based workloads. So that is CoreView, and it is very cheaper solution. So whenever you require GPUs on demand at scale, right? People go for CoreView. So whenever you talk about general purpose compute resources, right? You go for Intel Xeon or AMD TP, YC versions. So in these scenarios, CoreView provide you very interesting solutions, right? So those who are interested to work on specifically on these generative AI cloud-based solution, CoreView is the option where you may think of instead of going for AWS or Azure, you can adopt these CoreView, right? It is especially designed to deal with GenAI workloads. Okay, so you can think of using that in your upcoming research or in your projects. Yes, it offers you the support of Kubernetes, which is widely adopted, right? I hope you know the advantages of Kubernetes. It's a containerization service, right? Whenever we talk about microservices, people nowadays are using Kubernetes, right? Specifically Kubernetes and Dockers, right? Because AWS is supporting Kubernetes, GCP is supporting Kubernetes. So even this CoreView is supporting Kubernetes, where you can have containerization support there. And yes, CoreView also support VMs, virtual servers using NVIDIA GPU with Linux or even Windows versions are also offered there. Right? Let us just list out some of the functionalities of CoreView. So when I talk about storage, yes, CoreWave, I'm not advertising CoreWave, but this is designed for AI workloads, right? So think of using CoreWave than AWS or GCP in future. Try to think about that because their main intention is to deal with these GenAI based workloads because see the storage aspects. So IOPS is very high. The amount of IOPS throughput is pretty bit optimized here. Input output operations per second, which supports by CoreWave. So networking, yes, it is built to power HPC workloads. You can scale up to 100 Gbps of speed here. So then, yes, closed source models like GPT, they are proprietary and are not openly shared, but they are accessible via APIs for developers to integrate their applications, right? So this is what generally closed source foundation models they do. Why closed source? Because typically closed to protect IPR, manage safety concerns and control commercial accesses. So only API calls you will get, right? Where we find closed source foundation model? We find it here, right? So closed source foundation model, you will get APIs, use the APIs to build your models, right? Or your applications. So I just gave the example of these cloud solutions. Then, yeah, I was talking about this closed source foundation model. So the foundation models are pretty bit large, as I mentioned, closed source foundation models. They are like GPT-3, right? They are all proprietary and are not openly shared. So that's why the name closed source foundation models, right? Why closed source? Because they don't want to disclose their, or they want to manage their intellectual property. You have something called as model hubs. I think in that architecture we saw something called as model hub, right? So what is model hub? So very widely adopted solutions like Hugging Face or Replicate. So they allow the developers to share, host, and access your AI models. So that is the model hubs. I think you may, to a layman terms, if I say it is something like a platform where you may share your LLM models or share your code. So that is where you may use these model hubs. So they are like a repository. Like GitHub, you have something called as model hub. Something like a GitHub where they use is a model hub designed for sharing your models, right? So they act like repositories for open source as well as closed source model, so they can easily deployable across the projects. So that is model hub. Very famous model hub people use is Hugging Face. Hugging Face is used by many organizations at many places as a model hubs, right? Apart from Hugging Face, you have Replicate also, which is a platform where you may share your models, AI models specifically. Like GPT-3, yes, is one of the famous closed source model where you have only APIs to access it. You have Hugging Face, an open platform for hosting a variety of models, allowing developers to fine-tune or develop the models across the multiple use cases, for often providing APIs for the integration. So this is the distinction between closed source model and what? Closed source model and model hubs. Okay. So yes, generative AI, it is GPT, right? So GPT basically in 2018 it was introduced. You are aware of that, right? So key innovation over there is, so they introduced the concept of unsupervised pre-training following the fine-tuned where transformer-based model. It is basically a transformer-based model, right? You have something called as decoder model, which is an example for a decoder model. Can you think of any decoder model? BERT, right? So BERT is an example for your, it is not a transformer model, right? So GPT is a transformer model. Whenever you talk about transformer, you have encoding as well as decoding, right? I will show you the transformer. I'll come back to this. Yes, if you talk about transformer, yeah, this is how your transformer architecture looks like, right? Any transformer architecture, you have something called as an input embedding, right? So you have an encoder, right? So you have a decoder, so you have an output probabilities, right? So this is how your transformer looks like. I think in the next session, Madam is going to show you the demonstration regarding these transformer models. But as of now, let us keep it in mind that there is something called as a transformer models, right? Or a transformer architecture you have. So GPTs, they are all basically transformer based architectures, right? So GPT is an unsupervised pre-training followed by fine-tuning, where a transformer based model was first trained on a large corpus of text data and then fine-tuned for specific tasks. Okay. So what is the impact? So the power of large scale pre-training language models enabling broad understanding of your language context. So then GPT-2 released, right? What is the difference between 1 and 2? Parameters have been enhanced, right? So you can have 1.5 billion parameters. The amount of the model size has been increased, right? So where we have something called as zero-shot learning, where model could perform the task it wasn't explicitly trained for, right? What is the earlier case? It is designed for specific purpose, right? So now the model works for which it is not been trained. So that's what we call it as zero-shot training or learning. So impact is you have something called as text generation, right? That is a new benchmark achieved in GPT-2. Text generation was initially kept closed source due to the concerns of misuse. Right? Text generation was one of the major takeaway of GPT-2. So next you have something called as BERT model. You have bidirectional encoder representation from transformers. So BERT got a very good success. I think next session Madam try to give demonstration on BERT model. But keep in mind, BERT model is not a transformer based model. It is just a decoder model. Right? We have an encoding as well as decoding. We don't use encoding, it uses only decoding. Major advantage is it introduces bidirectional approach for textual understanding. Basically, considering the text from both left as well as right. So impact is if you are dealing unlabeled text. In previous case, it should be unsupervised, right? So now even you can deal with unlabeled text. That is the major advantage of BERT. BERT is basically bidirectional encoder, right? We are not using decoder. Right? That is why you can't tell it is a transformer model. So this is about BERT. Again, in BERT you have different flavors of BERTs was released. In 2017, in one paper they released transformer architecture like attention is all you need. You just refer this paper. It is a very interesting paper. Initially they gave the concept of BERT. In 2017 December this has been released. So basically it tries to highlight translate multilingual text automatically. Right? So how these multilingual text can be automatically converted. So that is one of the stepping stone towards the BERT model in 2017. Then one more paper you can refer in 2018, pre-training of deep bidirectional transformer for language understanding, where the actual BERT architecture with left and right has been discussed over. So basically at this point in time, the transformer went beyond NLP. Till now it was only NLP based model. So BERT, it went above the NLP. So the future of AI is no longer about the robot or sentimental robots or self-driving cars. Beyond that, you have a lot of things. So that is what the BERT tries to highlight. So earlier to BERT, you have word to vector, you have a neural conversational model, you have embedding of language models, you have a lot of other models designed. So let me jump to the BERT model here. See, the BERT basically takes care of left and right model. The importance is for bidirectionality is RNNs are pretty bit slower, right? BERT models are pretty bit faster because RNN, if you talk about RNN, who are aware of image or your ML models, you know how RNN works. Output of one is required act as an input for the next stage, right? It is a pretty bit slower process, right? So importance of bidirectionality is that is because the processing text sequentially in one direction is very costly, right? It is slow. So that's why BERT deal with bidirectional. So this is the key information here where the humans don't read the text in an absolutely pure sequential manner. Where if you see, you have a reading mind, we don't read the letter by letter. We read the letter in the clumsy manner, right? We don't read VIKENAND, Vivekananda, right? So we will read in a entire clumps, right? So based on that, the BERT model read your what do you call the textual data. Yes, just to give an example here. Okay, so the mouse was on the table near the laptop, right? The mouse was on the table near the cat, right? So the contextual differentiation is ELMO trying to differentiate the meanings of mouse in incorporating the context from both directions, right? So contextual differentiation cannot be done over there, but BERT model does this. So because mouse nearer to laptop is different, mouse was near the laptop is different, and mouse was chased by the cat, that is different, right? So the context need to be understood. So bidirectional model will take care of that. Your BERT model will take care of that. You use your ELMO or the other models, so they fail to understand the context. You treat that mouse, whether it is a laptop mouse or the animal, right? So it works based on the context. It will not be adopted, right? So BERT helps you to do that. The limitation, few more limitation is, context understanding is one of the major issue in case of the earlier models, which is handled effectively in bidirectional model. See the animal, street, it, right? So you talk about the animal, it, right? So it has to be contextually taken care. So that is very effectively done in BERT models. So yeah, some of the importance of bidirectional, if you just list out. So processing is pretty bit fast because left and right parallel you are doing it. So parallel processing you are achieving, positional encoding you are doing, efficient lookup of required text. So non-directional processing. So these are all some of the importance of your bidirectionality, especially in BERT models. Anyhow, madam will show some examples on that. You will be pretty bit clear once you see the code. Yes, it works on the concept of tokenizers. I hope in BERT you are aware the entire model works on the tokenization concept. Here, yes, the hug is 10. You just prioritize it, or you give a number, right? And TUN is 12. Let me give an example here. Here, H followed by U. Whenever you find H followed by U is present, right? That is 10 plus 5. You make it as 15 times. Means 10 times in the 10 occurrences of hug, 5 times in the 5 occurrences of hugs, right? So that is how your tokenization is done in the BERT model. So hugging face also, why hugging face? Because the more amount of tokenizer libraries you have when compared to BERT. So the library of tokenizers is pretty bit high in case of hugging face. It shows how the base vocabulary is created based on the frequency of words in the training data. So let us see the example here. Learning, if you say you have a subset of tokenization, subset of words instead of words like LEA, RN, ING. For learn it is LEA plus RN. Right? You have a lot of, your library is pretty bit high in case of hugging face when compared to the BERT models. For example, a few more examples if you see like subwords like burn, BU plus RN, churn, CHU plus RN. Turning TUR plus RNN plus ING, right? So you have a lot of sub words defined in case of hugging face when compared to the BERT models. Yes, hugging face, small vocabulary size. So the model like BERT use a compact vocabulary for about 30,000 tokens over there. Efficiency because it avoids the token that manages to cover a wide range of language data. Then word separations are also handled very effectively in case of hugging face. Yes, it is a prominent organization in the field of AI, where it is an NLP model where it provides a wide range of tools and resources for developing, training, and deploying the state-of-the-art NLP model. So that is major advantage of Hugging Face. So Hugging Face key components, you have a transformer libraries, which is open source library with pre-trained NLP. So dataset libraries you have tokenizers libraries, model hub, interface APIs, training and deployment. So these are all the functionalities of Hugging Face offered when compared to the rest of the models. So you have one more solution, as I was highlighting in Model Hub, you have Replicate, right? So Replicate is it refers to creating AI model that that can replicate or simulate human abilities, tasks, and other complex systems. And compared to Hugging Face, replicate offers you human capabilities. Hugging Face does not have human capability, it is just a enhancement of subset of these models, right? So replicate, you use the replicate whenever you want the human capabilities need to be introduced into your models. Okay. So replicating AI models where it involves duplicating or copying existing AI models for using different applications. For example, pre-trained models like BERT or GPIs can be replicated, fine-tuned for like language understanding, translation, text generation. So replicate is widely used. So simulating human intelligence, as I mentioned, replicate is used whenever you want to simulate the human intelligence. Like replicating AI could involve building systems that mimic human cognitive processes. Then use the replicate. So it supports that, and it automates the tasks with AI. So this is the replicate functionality. So whenever you talk about GenAI languages, you have R, right, like Python, Java, Lisp, Prolog. So these are all the different programming languages which adopts GenAI. So Python, we know the advantages of that, right? So Java is a good choice for AI development. Even Lisp, one of the oldest well-suited development for your AI models. Prolog and R programming is also widely used for GenAI. So these are all the generally programming languages we use. Just try to wind up this. We started with AI development stack, right? So this is the latest AI development stack in 2025. You have an infrastructure hardware, right? We saw in the beginning, which is a basic architecture model. You have an NVIDIA support 4G, which is talking. You have Databricks, which is widely used nowadays, right? So this is the infrastructure hardware in your AI stack. So you have foundation models like OpenAI, Cohere, right? So which are widely used. Databases you will find like PGVector, Pinecone, right? Again, Pinecone is used in most of the projects. Then you have a runtime like Hugging Face, Replicate, which I was highlighting. So this is about runtime. And front-end hosting, you have Vercel. So LLM operations, ops will find like model training, model evaluation, fine-tuning, model serving, right? So this is a stack you will find in 2025 with respect to AI, right? I think we started by discussing about the basic AI Gen stack, right? And this will be the upcoming Gen stack with lot of support from multiple marketplace, right? So this is the basic layering model with respect to Gen AI. Okay, I hope this is pretty clear. Any clarifications required? I'm not going in depth about BERT and other things because I'm leaving it to madam. She will take care of all those things in detail again. So let us move on with securing, right? So what is the possibility of attacks happens in GenAI and what are the possible solutions? So securing, so GenAI obviously plays a very important role in cybersecurity. You will find a lot of these challenges in GenAI, something like pattern recognition. Right, GenAI can learn from patterns in cyber threats and security documentation to enhance the threat detection. Right, so when you talk about predictive capabilities, right, you just historical cybersecurity data can be your input data is itself wrong. Right, so then in this case, obviously, predicted output will also be stale thing. Right, so then enhance with tool utilization. So AI can maximize the value of existing security tools by providing deeper insights and predictive analytics. So security measures need to be taken and we require some proactive measures to deal with this cyber security attacks. Okay, major advantage, GenAI models are very efficient because you can accelerate the threat detection, right? It is not like tomorrow threat will happen, day after tomorrow you find it out, right? So using the GenAI models, we know the advantages of GenAI. Adopting GenAI in cybersecurity will enhance the detection capability and response time will be very high, right? Responding to the cybersecurity attack is very fast if you adopt GenAI. And in-depth analysis can be done where you can think of root cause analysis can be done very effectively. So proactive threat detection, right, where you may shift cybersecurity from reactive to proactive. Reactive is you let it happen and then you react, right? So whenever you use GenAI models, you may proactively handle them. So this is the advantages of adopting GenAI in cybersecurity. Yes, there are a lot of issues because we know major issues with GenAI. The amount of resources required is very high, right? So high computational resources are required, right? And storage requirement is very high. You can't stick on traditional CPUs. Initially we learned, right? There is CPU, GPU, TPUs, and what else? Apart from TPU, yeah, FPGA, right? So the resources requirement is very high. That is one of, you may consider that as a con of using GenAI model for cybersecurity. Risk of misuse is very high because whenever GenAI tools are exploited by cyber criminals, so they may have a sophisticated attack, right? So they may use the tools for have a sophisticated attack. Recently we saw, right, what happened with the pager attack, right? So if a cyber criminal are exposed to these GenAI models, I think easily they can handle effectively. So ethical consideration, yes, because privacy and data control concerns do arise whenever you are using your AI models, right? So I'm talking about what are the challenges of cyber security which can be handled by GenAI. We try to understand what are the pros of adopting GenAI in cyber security. Some of the issues, right? Actually, these are not the issues, but the matter of concern when you are adopting GenAI for dealing with cybersecurity. Okay, what is the scope of talk? If you see, these are the areas which are exposed to attack. I think whenever you talk about cryptography or cyber security, you know, you talk about different levels of attacks do happen, right? So in GenAI, you have hardware level threat. I think if you recall your layer model, what was the layering you find? You have hardware, you have OS, you have software, right? And then at the base you have to deal with data, right? All these are exposed to attacks. So hardware level threats, they exploit targeting AI hardware, accelerators like GPU, TPU, right? Whatever we learned about GPU and TPU, so that can be easily attacked. Because your GenAI model does not work on a traditional CPU, right? It requires specialized accelerators. So that hardware attack comes under that. We have OS level threats where vulnerabilities can exploit to affect AI workload and data integrity. I will give you some case studies on that here. Software level threats like bugs and vulnerabilities in AI framework applications can lead to security breaches, right? So then data level threats where training data itself can be corrupted. If your trained data is corrupted, obviously your output will also be impacted, right? So these are the different types of attacks do happen in GenAI. Yeah, let us talk about hardware level attacks. Whenever we talk about hardware level attack, as I was highlighting, what do you mean by hardware level attack? What hardware level attack? Your optimizers are attacked, right? Like CPU, GPU, TPUs, all these things are under threat. So these are some of the scenarios, or you may say attacks people have done, like memory access attack. We have something called as side channel attack. We have something called as hardware manipulation, right? So what is that memory access attack? The memory access attack, I will give you an example here. Yeah, you have something called a Spectrian meltdown vulnerability. See, whenever, if you want to access a hardware or any, you call the register memory, right? You want to access a register. Whenever an application wants to access a register, if it is eligible, it will give you the permission, right? So if it is not eligible, you can't access the memory location, right? So in case of Spectrian meltdown vulnerabilities that has happened, that is memory access attack. So attacker exploits the vulnerabilities in how hardware manages the memory to leak the sensitive data. So that is kind of attack in a hardware, like memory access attack. No, not all the applications, not all your program threads can access the memory, right? Only the specified set of codes can access it. For example, you have, meltdown attack. What happens in meltdown attack is whenever any application wants to access a report, or whenever they want to access any memory, right? If he is eligible, he can access it, right? If it is not eligible, he will get an exception. But these Intel codes, what they have done is, they have designed our architecture such a way that even if he is not eligible, the memory will be there in your cache. Why they do that? Because they want to enhance their processing capacity. Intel, they want to do that, their processors are much faster. But actually, you are not supposed to read the memory, because he's not an eligible person, or this entity is not an eligible entity to access the memory, right? In spite of that, it reads the memory and stores it in the cache, right? So that has led to meltdown attack. See, this is what happens in meltdown attack. Unprivileged user prefetch the request and requires the kernel data, right? CPU prefetches the data from your kernel memory. So whoever is not privileged should not read it, but unprivileged user measures the difference in processing time and reduces it. That difference in processing time is called as side channel attack. What a side channel attack is? The attack involves monitoring the physical signals like power consumption, electromagnetic signals, and you take okay, this is the time taken for reading the data. So based on the signals, they'll try to predict what kind of data you want to read. So that is called a side channel attack. So they have demonstrated how power analysis can reveal searches from secure hardware component. Your hardware is secure, but your hardware is emitting some signals, right? So whether the signal with respect to what you call electromagnetic emissions or power consumption signals, right? So they start the time it has started and it will end, right? So then they try to predict the data. That is side channel attack. So using side channel attack, they will find out what type of data it is reading. You have an hardware manipulation where physically you tamper or maliciously modify the AI hardware, where they can introduce you like your trojans, use your trojans to read the data. So that is hardware manipulation. So these are all the kind of attacks comes in hardware level attack, right? So I was highlighting regarding what are the different types of attack your GenAI model may face. One is hardware level threat, the other one is OS level threat. Right? In hardware level threat, you are exposed to memory access attack, side channel attack, hardware manipulation attack. So you have the hardware accelerators, as I mentioned. There are two famous attacks out there. One is meltdown and spectre attack. Just give the comparison, then you will come. Yeah. Meltdown, the processor like Intel, as I was mentioning, the Intel board manufacturer, what they did is an unprivileged code can access the data, right? But you should raise an exception. But what they do is, so they prefetch the data and store it in cache, so that you can, in future, if you get the privilege, you can read the data, right? So that is the meltdown attack. So spectre attack. So in spectre attack, you do something called as speculation. You speculate the data. Let me highlight what is this speculation. I think you know about what is this? Fetch, decode, execute cycle. I hope you know how your computer system works, right? You have fetch, decode, execute, right? 3 cycles. What happens here is, in pipeline and branch, this is the regular process you do, right? So some of the instructions are to finish before the next began, right? Whenever the execution depends on the results of one of the instructions, so instruction B or instruction C, next depends on the outcome of A, and they are waiting, which wastes the time. Right? Let me assume B and C have completed before A has done. Fetch, decode, execute program. Right? Once A is done, then B is done, then C is done. I think in operating system you know this concept, right? This is how it works. Sometimes what happens? Instruction B, C, D, E has completed early, but A is taking a lot of time. What happens? This is wasted. This time is wasted. The processing time is wasted. To handle that, what these processor architecture they do is they do something called a speculative execution. They speculate. Okay, what may be the next outcome? To save the time, the processor predicts that next instruction, what the next instruction will be. He is waiting for the next instruction, A to complete. But A is taking more time. What is speculative do? What is processor do? They speculate. Okay, A is taking more time. Let me assume what will be the outcome of A. Right? Some of the board manufacturers they do that. That is speculative execution. Okay, so that has led to spectre attack. Okay, you have two kinds of attacks in the hardware. One is people have encountered. One is meltdown attack and spectre attack. I hope you understood what is meltdown attack. Meltdown attack happens because of basically whenever you are using Intel boards, it is exposed to meltdown attack. We will see the solutions for that. So whenever you are using ARM, AMD, right? So these guys, so they do speculation. So spectre attack is done on these boards. So method, so there are out of order execution, right? Then here speculative execution or branch prediction. this is the method they are using, right, to deal with, because of this spectral attack has done. So attacker must be able to execute the code on the target system. Here attacker must be able to execute the code on the target system as well as exploit the possible through web-based attack. Right? You are speculating something, right? The entire speculation will be attacked, so that your answer will be wrong. Your speculation is wrong, right? That is in case of speculative attack. So impact, where kernel memory, physical memory from the user space can be easily accessed. Even unprivileged user can read the data. Right? But here in case of to reach the memory of a target or victim processors running on the system, attack needs to be tailored for the target processors. It is a variant of attack that can be used in virtualized environment, in containerization and other things. These kind of speculative attack can be very effectively done because you are speculating the output. So solution is, in case of meltdown attack, operating system patch specific to meltdown, hardware level fixes need to be done. Right, your architecture should be redesigned. That is one of the solutions, and operating system patches need to be handled for specific meltdown. So here software patches are required, hardware execution is modification is not required. You take some BIOS or firmware updates to deal with this spectral attacks. So what is these kind of attacks? Related to hardware level attack, right? Just I think I'm running short of time. I'll quickly go through these things. Yeah, anyhow, sharing these things. What is the process of meltdown attack and what is the process of spectral attack? You can go through this easily and understand. Yeah, spectral attack, people have found a lot of spectral attacks, like variant 1, like branch direction prediction. Second variant, people have identified like branch target buffer. So different types of spectral attack. I hope you got to know what is meltdown and what is spectral. So there are different variants. Like in viruses, we have different variants of viruses of COVID we find. Like strains we find. Same thing, different types of strains of spectral as well as meltdown attack you may encounter. But these are all related to GenAI kind of attacks, right? Next you have, mitigation. You think of isolating your processor resources like MIT, they have a solution for this DOC, where securely partition the processor cache, preventing different programmers from sharing the resources and reducing the risk of side channel attack. Side channel attack can be reduced. What is side channel attack? Side channel attack is the kind of attack where based on your electromagnetic signals, you can easily find out what is the time of data read starts, the time of data read ends, right? To speculate something. So that is a kind of side channel attack. Because of that, your meltdown attack is happening, right? So you have isolation. You may isolate your processor resources, like cache memory can be isolated. You may design a new CPU architecture, scrap your whatever techniques Intel or AMD is using. Why meltdown attack is happening? Because they are reading, right? Initially, even unprivileged instructions are reading the data, right? Why speculative attack is happening? Because of speculation, right? So redesign the architecture. Speculative vulnerabilities have existed for over 20 years. Speculative meltdown exposing critical hardware security risks beyond the software concerns. So that has to be handled. And you have different variants. For every variant, you have to release a new solutions or a new patch which has to be installed. So security as a priority. So future CPU designs must balance the performance improvements with respect to security, emphasizing protection against side channel attack. Handling side channel attack is a major concern. If you deal with side channel attack, rest of the things can be effectively done. Because you may redesign your architecture, you may redesign your code, but handling side channel attack is a major challenge. So this is about hardware attack. You have something called as OS level attack. So OS level attack, so it is the backbone of any AI system. So AI workloads dependent on OS for system calls, memory management. I hope you agree with that, right? Any AI, so they depend on OS. Why they are dependent on OS? Why your AI workloads are dependent on operating system? Obviously for memory management, for system calls, process scheduling, right? Because of these things, your AI workloads are dependent on operating system. So critical attack surface is our operating system, right? So imagine a cloud-based AI platform running on multiple models where different users deploy application. If an OS vulnerability allows unauthorized users to escalate the privileges, then sensitive AI model data can be easily handled. Right? So that is OS level attack. So I'm classifying different types of attack. One is hardware attack, the OS level attack. Let me show you some examples of this, what has happened. One example for OS level attack is privileged escalation. Privileged escalation attacker exploits a zero-day vulnerability in an OS kernel, where if we know that there is something called as ring in our computer architecture, ring 0, ring 1, ring 2, right? Whenever we talk virtualization, our hypervisor sits at which level? What is an hypervisor? Whenever we talk about virtualization, we create VMs, right? Your VM should get the highest privileges to access the hardware, right? It occupies ring level 0. Generally, operating system sits at ring 0. Whenever we talk about hypervisors, so they acquire ring 0, then your OS will be shifted to ring 1. So something that is ethically correct, but here in case of privilege escalation, what these guys will do is, so they allow manipulation of AI process and data by moving your OS kernel and gaining the root access. So that is one of the examples for OS level attack. Right? So one more example is memory management flaws, especially requiring larger memory. They may expose memory leaks, buffer overflows, right? So that is one of the kind of OS vulnerability. And shared resource attack, because AI workloads often share the GPU resources, right? The OS does not properly isolate it. If you don't have sandboxing, right, among the what do you call multiple applications, then obviously that we can classify it as an OS level attack where data leakage do happen, right? So yeah, whenever we talk about containerization, they basically handle this OS level attack, which we call it as container escape. As I was highlighting, what is container escape is, it is a scenario where attacker leveraged a weakness in the OS virtualization layer to break out of their container and gain access to other users' AI model as well as data. So that is the container escape. So we know what is container. I think this is out of the scope of this discussion. We know what is containerization, right? So this is our traditional computer architecture, VM architecture. You have containers. What is the difference between a VM and a container? Are both one and the same? Virtual machine and containerization are one and the same? Yes or no? Virtual machine is containers, right? No, I am asking you what is the difference. Let me know what is your understanding. What is the difference between a containers and a virtual machine? I think this diagram will clearly help you to understand. What does a container does? Containers don't generally for microservices. Do we use VMs or containers? What is a microservice? If you talk about your Flipkart or Amazon, right? So billing is one service, right? Somebody has designed it, right? Your what do you call your inventory is a different service, right? So these are small services, which we call it as microservices, right? So microservices, they need containers. They don't use VMs. VMs means you are using your resources, right? A VM contains hardware. You have a guest operating system, and you have a host. This is a host operating system. You have a guest operating system. But here you don't have an operating system, right? Operating system, whatever underlying operating system is, that is used. But you have your own binary libraries associated with the application. I have designed one billing service. I will embed my billing service with my library and I will share with the customer, right? So my container is not consuming the resource of mine, right? But your VM is consuming the resource. It is pretty bit heavy when compared to a container, right? So container escape. Why I am trying to this is, there is something called as container escape, which is an example of what OS level attack in our GenAI. So what is container escape? So in case of container escape, people may associate container escape only with the ability to execute a program within the containers of the host system. So it involves attacker leveraging the containers to steal the data from the host and perform the privilege escalation. Right? So privilege escalation do happen. So that is called as, what is privilege escalation? Just now I highlighted ring 0, ring 1, right? So privilege is escalated and he captures your entire hardware, right? Through operating system. So this is one of the examples to deal with OS level attacks. We have some examples for container escape techniques are there, using user mode helpers, release agent attack. These are all some of the examples of container escalation. See, this is what happens in container escalation. So you have an implicit here in your container. So engine, you are accessing your root. Okay, so that is container escalation, container escape. There are a lot of solutions you will find for OS level faults. You have patch management, you have OS hardening, right? Privilege management, intrusion detection and prevention system. So these are some of the examples of OS level or to mitigate the OS level attacks, right? There are a lot of other things are there. Already running short of time, I'll skip that. Next, you have third thing called as software level attack, right? So software level attacks, where the vulnerability, software vulnerability for misconfiguration, unpatched libraries, insecure APIs usage in AI models and applications are done. You take an example of an OS application level. A machine level model deployed in e-commerce application uses a vulnerable version of TensorFlow. What will happen? Attacker exploits the known vulnerability to execute the arbitrary code. Okay, I think I will show you an example. Yeah, Trojans are used, where infected Trojans are added to your application so that the entire application will be hijacked. So that is a kind of attack. You see again different types of Trojans they use, like you have a downloader Trojan, backdoor Trojan, spyware, rootkit Trojans. So different types of Trojans are used to deal with this kind of attack. So again, to mitigate, you adopt a secure AI development cycle, like code review, real, and continuous software security assessment. Use secure software libraries so that you can mitigate the software level attack. So next you have data level attacks. Yes, data level attack basically, see whenever you talk about data level attack, you have poisoning attack as well as you have something called as evasion attack. See what happens in poison level attack is your trained data itself is modified. Right? What happens if your trained data is modified? Obviously, trained data is used to build your AI model, right? So if your trained data is modified, the entire outcome is wrong, right? So that is one kind of attack. You have something called as evasion attack, vulnerabilities in security systems where you use various malicious activities here, right? Or you bypass your detection method. You have some X detection method, you change it to Y detection method, right? You attack your model itself. So that is evasion attack. You have two kinds of attack in data level attacks. One is poisoning attack and evasion attack. In poisoning attack, you modify your trained data. Evasion attack is you change your model itself. The attacker will attack your model itself. So, for example, very major concern is self-driving cars, right? So people will change this. You have a stop symbol, they will put the stickers on this, right? Then obviously it will affect, right? The car will not be stopped. It will be trained such a way that whenever you see that particular symbol with these characters, with this font, this style for stop, your autonomous vehicles act accordingly. If you are, this is, what do you call it, misread, then obviously it won't stop, right? So that kind of attacks are called as evasion attack or poisoning attack. That is a kind of poisoning attack, right? So input data is wrong. What is evasion attack? Your model is changed. The method, you have used X method, change it to Y method, right? Your intruder will change X method to Y method, that is an evasion attack. So these are the scope of doing research. Generally, whenever you pursue research in GenAI, people will just use APIs, right, and predict something, right? So you have a lot of options to do the research here, right? You may provide your own solution for poisoning attack, you may provide a solution for evasion attack, how your model can be saved from the attack. Right? So you may think of in this regard to deal with these attacks in cybersecurity. So there are a lot of solutions do find. You have like data validation and sanitization. Before the training data is handled, you deal with data validation and sanitization, right? And integrating with monitoring during training, right? You employ model explainable technique, like there is a sharp values to monitor model behavior and detect potential poisoning. So you will have a lot of solutions you may adopt to deal with data poisoning. Yeah, this is what I just want to sum up here. We learned about what is GenAI. We learned about two stacks, very basic stack, 3-layer model. Then we find in 2050 what should be the GenAI stack model. Right, sufficient to cover that. Then we try to understand what is the importance of cloud solutions, right? Since people are aware of AWS, GCP, and Azure, and that's a little bit about more right? So we have pre-trained models. I try to cover them Hugging Face and replicate, right? And in this scenario, you go for Hugging Face or replicate. So these are different types of attacks, like hardware attacks, OS level attack. Just gave examples for under hardware attack. These are not only the attacks. I'm just listing few of them. There are hundreds and thousands of hardware level attack, OS level attack, software level attack, and data level attacks. One example under each category I will try to touch upon. Hardware attacks, you have meltdown and spectre. OS level attack, you have containers escape. Software level attack, you have trojans. Data level attack, you have evasion and adversarial attack. Right? So actually, I had much to be discussed in detail. I had only 1 hour because madam is waiting for again dealing with this hands-on session. So I'll stop here. I'm sharing these materials with you. It is very elaborately discussed. I have given an example for meltdown spectra. If you go through that, I think now easily you can understand the topics. And while doing your projects or your research, I think you may consider of taking these problems and try to provide a solution. Consider a meltdown attack, or consider a container escape, or take an evasion attack, try to provide a solution for it. So that is GenAI plus cybersecurity, which is the emerging area. Okay. Thank you. I stop here. I think I'll give it to Madam. She tried to handle some hands-on session, some demonstration. Another 1 hour. Okay, Madam, another half an hour she give the demonstration. Then you can go to lab for
Thank you, Siddesh, for sharing valuable information with all of us. So really, it was a very good session. Thank you so much. So on behalf of Vivekananda Institute of Technology, we would like to present a moment as a token of our gratitude. Thank you, sir. So now we'll take a short break for tea. So after that, we'll assemble back, and Jamuna madam is going to continue the session. I request all the participants to come back quickly. So welcome back. Let us start the second session. So now we have with us Jamuna S. Murthy. So let me introduce her. Jamuna S. Murthy is currently working as an assistant professor in computer science and engineering at Ramaya Institute of Technology, Bengaluru. She previously worked in Pesu University. She is known for her consistent academic excellence and has received the Best Project Award for her MTech thesis in 2017 from Ramaya Institute of Technology. She is currently pursuing her PhD in deep learning. She has also secured DST funding for developing FitCure smart water bottle from 2020 to 2022. Specializing in cloud technologies, Jamuna is certified in architecting with Google Compute Engine by Google Cloud and is recognized as a certified educator. Her research has been presented at prominent international conferences, and in 2024, she published the book Cloud Security Concepts, Applications and Practices, which was released internationally in New York. Her work is featured in leading journals like IGI Global and Citizen. Her main research interests include cloud security, big data, and data science. She is an active member of the Association for Computing Machinery, the National Society of Professional Engineers, NSP, and IST. So we welcome you, ma'am. I request Professor Shailesh sir to welcome her. Thank you. Over to you, madam.
So very good afternoon to everyone. Sidhu sir already showed about, yeah. Sir already gave a conceptual explanation about some of the technologies related to generative AI. So whenever we talk about generative AI, there are many models that comes into picture which are related to generative AI, which were discussed as Hugging Face hub models. So basically, the major difference between a technical difference between a normal model execution and GenAI model execution are basically we are focusing mainly on fine tuning. So we are fine tuning the model. We are not doing anything like training the model. So if at all we have to train, we need a lots of GPU support. So TPUs will not be a solution for any kind of a GenAI models. So we will be using a lot of GPUs, and even the GPUs will take lots and lots of time. So in such cases, we'll be doing something called transfer learning. So how many people have heard about transfer learning? So I think, let me just give a small brief before getting into technical concepts. So transfer learning is a technique where we are taking the model which is already pre-trained, okay, and then we add several classes that has to be trained on top of it. That is addition of new classes, right? So this is the concept of transfer learning. And another thing, we talk about fine-tuning of a model. So what do you mean by fine-tuning of a model? So whenever we talk about any kind of a deep learning models, which even generative AI models are covered there. So in that we use something called epochs and hyperparameters, right? So whenever we talk about fine tuning, it is majorly hyperparameter tuning. So what are the hyperparameters are you people aware of? What are the hyperparameters that you people are aware of? Very simple hyperparameters before going to the code. Yes? Any idea of optimization techniques? Optimization? Adam optimizer? RMS prop? Okay. What about training epochs? Do you know what is training epoch? What is an epoch for training? So epoch is something which is used by training the data. Okay. So next particular very important parameter, which is learning rate. Do you have an idea about learning rate? What exactly is a learning rate? So please note down, these are very important for you to actually run this code, because understanding the code is what we are focusing here on. Okay. So first of all, I'll be starting with text extraction. Okay. So I'll be starting with text extraction using BERT model. So BERT is an architecture, it is actually named as bidirectional encoded architecture. So typically we are not using any kind of a decoder, right? So in particular architecture of BERT, so these are the references that I'll be using for the code. So first one is BERT and SQD. So if you click on this link, it will take you to the paper. If you need a detailed understanding about the BERT model and also the architecture, you can actually click on the link and understand more about it. So apart from that, we have something called Stanford question answering data set. So why do you think this is a very basic model that we need to know? ChatGPT is using a lots of LLM models which are pre-trained models. It is not using only one particular model. It is using a list of pre-trained models, right? So BERT is one such model which is very important for generative AI, very basic model which you need to understand before learning LLMs in detail. Okay, so that's why learning BERT is very important. So whenever you are working, so let's say I have given you this collab file. Okay, very major important thing that you need to do is you can even upload it to your collab library or a database, that is Google Drive, or else you can even run it on the Anaconda. Why do you think we have to use Colab? Because Colab will provide us GPU, TPU facilities, so it's a good option for us to run using the Colab. So first is, let's say you need to store some data. So for that, I actually have to connect it to the Google Drive. So connecting it to the Google Drive, you need something of this sort of a command, that is from Google Colab import drive.mount/content/drive. So if at all, let's say, I don't know anything, how exactly do I start? So very simple thing, if you just click on this drive icon, it will directly copy the cell. Okay, so let's say I have to mount something, so if you just click on this, in the cell, this contents will be directly displayed. Even though you don't know the code, it will be directly displayed. This is a very shortcut. Okay. Then you need to give a connection request where it will be connected to your drive. Next set of things that are very important are the libraries. Okay. So if you look at import OS, it is operating system. Why do you think I'm using OS? Because I am connecting it to the drive. Drive is a database and it is connected to an operating system, so import OS is related to mounting the drive. That's why I am using something OS. Okay. Other example, let's say I have to take the data set from the drive as a link, file name. So files are part of operating system, right? So import OS is very important. First particular collab book, I'll explain everything. Next collab books are very easy. Okay. Next, RE is regular expression because it is related to text data. You saw already how to divide it into chunks and then we proceed. So next is JSON, that is for JSON file format. Next is string. Okay. Another important thing, whenever we have to do any ML or DL task, we need pandas, numpy, matplotlib, sklearn. Okay. Other than that, there are something called TensorFlow and PyTorch. We do not call TensorFlow Keras and PyTorch because now Keras is included with TensorFlow. So TensorFlow and PyTorch are two different kinds of libraries that we can use, install and use. Okay. So for installing TensorFlow, you can directly give pip install TensorFlow. So very important, pip install TensorFlow will actually help you to work with the TensorFlow. Okay. So you need to install and then you need to work. Even NumPy, Pandas, sklearn, you need to install them, pip install the library name, Pandas, NumPy, matplotlib, then only you can use it. Next, TensorFlow as TF. So this is a short form. Instead of using TensorFlow every time, I'll use it as TF. Next, from TensorFlow, import Keras because Keras is part of TensorFlow. Again, both are libraries. So when I compare TensorFlow and PyTorch, PyTorch has inbuilt GPU facilities. If at all you want inbuilt GPU facilities, go for PyTorch, or else you can connect to the GPU like V100, A100 with TensorFlow. Advantage of using TensorFlow, n number of libraries. It supports n number of libraries, but PyTorch do fall short when it comes to libraries. Best option for higher level models, go for TensorFlow, or very simple GPU intensive tasks, go for PyTorch. Okay. Next. Any deep learning model will have number of layers. We have input layer, output layer, and in middle hidden layers, right? So to configure the layers, we have something called TensorFlow.keras. We need to import something called layers. Okay. So that's why for deep learning layers, we use TensorFlow.keras from layers. Okay. Next, another thing, even a model like BERT is a deep learning model. Okay. It has been trained, but it is named as a pre-trained model because weights are available for you to do any kind of a task. So for that, definitely it is a deep learning architecture, so layers are used. Next, tokenizers and BERT word piece tokenizer. So what do you mean by a tokenizer? When I talk about a tokenizer, I have a sentence and I'm doing word level analysis. Then I have to divide the sentence into chunks or words. Right? So that is something which is tokenizing. That is, you have a sentence and you need to divide it into words. Alright? So that's why we use tokenizer, and there are pre-built libraries, n number of libraries. In that we are using word tokenizer model here. Okay? From transformer, I am trying to import word tokenizer, TF word model, and word configuration. Now, BERT is a kind of a transformer architecture, but we already mentioned it does not contain a decoder. But we cannot tell that it is not a transformer model. We cannot tell it's not a transformer model. It is a transformer model. That's why from the library, we need to call it from transformers. Again, you need to pip install transformers. Okay? You will get an error. In that case, if library is not installed, directly go for pip install. Or else you can go for TensorFlow. Anything you want to install, go here. There is already documentation, predefined documentation. It will help you to install anything and configure. Okay. So let's get back to this. Let's say your code is supported with 2.11 version, but currently you have 2.17 version. Okay, TensorFlow Lite will support 2.17 version, is the latest stable version. This particular code is 2.11 version. Why do you think this is very important? Because some codes or some libraries will have version control mechanism where you have to identify which particular TensorFlow library or which particular version you are actually running. So then you can do any kind of a changes for the further code that you try to create. Okay. So I have shown here a simple example for a demo. By default, it will be a default version of, let's say, 15 or 17. So I have installed 2.11 to just show you that it is, you can actually install the version you want. Okay. Pip install TensorFlow equal to give the version. Chuck the code, give the version accordingly. Okay. So it will install the particular library. So you can see lots of things are installed, TensorFlow board, estimator, all these are part of TensorFlow. Next, let's go to the tokenizer. So why do we have to use tokenizer? I already told you. When it comes to the tokenizer, you will have to take the information as a sentence or maybe a document. You need to convert it into chunks. So for that, we use something called a BERT tokenizer. BERT tokenizer I already imported from our transformer model. So here, if it is present in the particular path, so what exactly is the path I've given here is BERT base uncase. Why do you think I've given like this? I'm not training anything. I already have the pre-trained model. I'm trying to use it. So I'm trying to take it from the particular path. So that's why I'm trying to load the base model, which is a BERT pre-trained model. I am not creating any architecture here. I am trying to load the pre-trained model. For that, you can set up a BERT tokenizer with the help of this code. You know this is a Python explanation where you're trying to load it, you're saving it in one kind of a variable, and you're trying to display. Alright. Next, you can see train and eval. So why do you think I have taken this? So in this particular example, I am trying to use something called a question answering data set. I can use BERT like a ChatGPT where I can ask question and get some answer. So for a question answering based approach from Squad, I am trying to import this particular data URL. So that is in the JSON format which I already imported. So this is JSON format and I am trying to save it in the file train.json and eval.json. Okay. So this is a particular example of loading the data. We need to actually load the data, and if at all it's a pre-trained model, you already have some weights which are available. You can directly validate the data or do some kind of a transfer learning. Okay. Next, pre-processing the data. So any ML task you need to divide it as what variables X and Y are called what variable, input variable and a target variable. Right? So X and Y are input variable and target variables. So we have X train and Y train, X eval and Y eval. X and Y are input and target variables, which is a normal process of a ML task. Same thing we are trying to include here. In the context of question answering, I am trying to divide this as this. What do you mean by self dot question is equal to question? What is self dot question is equal to question? Any idea? Technically, we are using a class concept here which has a constructor. When I call it as self, it's a kind of a constructor, right? We have learned this in OOPS, Java. We have constructors. So here we actually call constructors as self dot. Anything which is self dot is called a constructor. Any new variable you are trying to define as an object inside a class, you need to use self dot. Very much of a self-explanatory thing. In that, I am trying to use pre-process function. What am I trying to pre-process? The context of the data, the question, and the answer text, and then a character index. Okay, start character index. Why is it important for us to start with the first character? Model has to identify where it is starting and where it is ending. Right? If at all I have any jump character, you can even include one kind of a variable where you include the jump identification, jump character identification. Right? So you need a end token and a start token. That is very, very important when it comes to any kind of a LLM model. Or you are dealing with a text data, simple NLP. Then, clean context as answer and question, you need to split it, take the string, split it into the chunks, and then end character identification has to be done so that it is actually ending with a particular sentence, and mark the character index. How do you think BERT is actually popular? BERT uses something called positional encodings, which are called as embeddings, right? So it has positional encoding. Whatever the data you give, like say Jamuna is an assistant professor. If at all I give assistant professor Jamuna is, it will identify and it will go in a sequence as Jamuna is an assistant professor, because it has positional encodings. Jamuna has to come first. So that is positional encoding. Even with respect to character, it holds something called character level encodings. That's why it is very popular in neural machine translation, which is a next example that is given. That is converting a particular word which is in English to Spanish or German, which is neural machine translation. So this is a simple example of tokenization. Then you have, for question answering, you have one particular index, start index and end index. Then find the start token and the end token, tokenize the question. Create an input here, what kind of input you are trying to give, it should be in terms of a text. And then you have something called attention. Very important when it comes to any transformer model, it is attention mechanism. So attention is all you need. A very popular paper will talk about attention mechanism. I gave one page of text to ChatGPT. Do you think it will read from starting to end in one page of data? I gave some text. I asked a question on that. Do you think it will read everything? It will take even more than days together for it to read. it will use something called attention mechanism, in which it will identify what is important in the text regarding the question, which is a POS tagging, which is an NLP based approach where verbs, nouns, pronouns are identified based on the question. A matching of the token will be done in the text. Based on that, you will get the answer. This is attention. Nowadays, a lot of popular papers are talking only about attention mechanism, which is self-attention based transformer technique, softmax suppression for attention, cross-attention mechanism. Lots of transformer architecture only talk about attention because the whole heart of a transformer architecture is attention. How fast do we get the information? So that's why it's very important for you to read that very base paper, that is attention is all you need. Okay, so then I generate an attention mask. Again, you can look into the constructors. I'm trying to define input ID, token, attention mask, start token, end token. So I will open the training data set, open the validation data set, load them, and then create some examples which are already available in terms of data, paragraph, context, class. You need to actually look into the data set, that is the question answering data set by Stanford. You will get a better idea of how exactly the data set looks like. Then create an input target for that as an IDs, and then we return the X and Y variables, which are very important as input variable and the target variable. So this will cover how exactly do I take the data, load the data, pre-process the data into tokens, start token and end token. Very important as a basic starter. If you don't know anything also, identify the start token and end token and pre-process. Very important for you to understand. There are 87599 training points that are created. 10,570 evaluation points that are created. Why do you think the validation data is lesser than the training data? Lots of data has to be trained, that is 70% of your data has to be trained, and then rest data may be used for testing and validation. Okay, training data should be large. Next, creating a question answering based approach for BERT model, that is ask the question, it will generate an answer, Gen AI, right? So asking the question, you have to define an encoder. For that I am using TF BERT model, which is a pre-trained model. Obviously I cannot train the data, I use a pre-trained model. Always understand when it comes to BERT, it is encoder architecture. So I'm using a Q&A model with input IDs, whatever the token that is, the length of the data. Again, when I'm giving any kind of a text data, when I'm giving any kind of a question, each transformer model will have a max sequence length. What is the maximum sequence length I can give as a question? So technically it will be 25. It will be 25 as the maximum sequence length in terms of words or characters that you can define. If you are doing word level, it might be 25, character level, it might be 25. You define what is the max sequence length. So you start by using a large dense layer, which is, what do you mean by a dense layer? Which has skip connections among them, which is a very basic architecture of a deep neural network. Dense layers are used in deep neural network. Apart from ANN architecture or CNN architecture, dense layers are basically used in DNN, not in any CNN or in any ANN. So dense layer, and I will flatten the data, whatever is the data that has been given, I will flatten the data. And then one more I am using, can you tell me what is one that is being used here? What is one? It's a neural network architecture. I need to specify the neurons. Okay? One will tell about a neuron. How many neurons am I using for computation? Okay? So in a similar way, very important for you to understand here is model compilation. So you can see here a model. Anything and everything that I am defining here in create model has to be passed as a parameter here. Why? Because it's a function. I need to pass the parameter, give the values, then only it will run. Very basic Python programming. So I am giving input tokens and then I am starting and ending with the output variable. I have a loss, that is an optimizer, which I am using sparse categorical cross entropy. You can ask a lot of questions about loss functions, but best particular example or loss function that we use is cross entropy, which is a very good suitable loss function for text. You can explore more about loss function. There are variety of loss function. The whole research of deep learning is only on loss function, that is how to optimize your algorithm and get the good result. So this is loss function. Optimizer, we know that gradient, whenever we are handling the gradient descent, how fast your data is converging, how slow is your gradients are converging plays a very important role. Optimizers play a very important role in convergence of the data. That is the gradients which are in terms of a numerical weights in your data set when you do any kind of a machine translation using neural network. So next we use a function called model.compile. The whole summary of deep learning TensorFlow Keras is model.compile, model.summary, model.evaluate. So which is the whole coverage of what is deep learning based compilation and getting the results. So I compile it and I return the model. So you can see here I am trying to use TPU. If at all I set it as false, it will not use the TPU, it will directly jump for GPU. This is just playing with the code to use GPU, CPU or TPU. What is available, I can use it. I have given a simple code in which, if at all I am using TPU, I can use TPU. Not available, jump to CPU, or else it gives you an error. So switching between the hardware components is very important. To show the demo of it, I have given something called TPU, CPU or GPU. Okay. So then it gives me the model summary, something like this. If you get this, then you are through. What do you mean by total trainable parameters and non-trainable parameters? Zero non-trainable parameters. Your whole optimization comes into play here. How many parameters are there? Do you think you can actually compile? What is the number that is there here? 100 million parameters. Do you think you can actually compile this with the help of a normal GPU? No. That's why it's called as a pre-trained model with n number of parameters. You can just use that as a pre-trained model and you can evaluate based on the already available weights. For that, what I'm trying to do here is, I'm trying to create a callback mechanism where you're trying to use the validation data to just get the answer or evaluate it. So I'm trying to normalize the text. This is again input I'm giving. It has punctuations, NLP task I'm trying to handle here, white spaces I try to remove. And then if at all it matches the sequence of a transformer model input, I will try to evaluate the model for whatever is available. Init is a function in class which is basic kind of a function that I have to use when it comes to constructors. Okay. So if you observe the code, I am trying to use something called epoch. Epoch is something which is very important, which will actually train the model from starting to ending using all the optimizer loss functions and accuracy values that are given. Okay. So when I say it's a best model, it might be 80%, 90%, average model should be 60 to 70%, worst model is below 50%. Okay. So for that I have tried to create one particular code in which I am doing a kind of an NLP call mechanism where I have to basically pre-process the data and get the input in the proper format. Then this is on epoch end. What happens at the epoch end? I will take the accuracy score and I will try to match it with the particular epoch. First epoch might give me 20% accuracy, next epoch might give me 30, 40, 50, 60. This is how you get your training and testing and validation graphs based on the particular values for the epoch. So on top of it, I am trying to evaluate the model with the help of training. So you can see here, I am trying to train the model with only one epoch here. So for a normal demo to get a good output, you can actually use 3 epochs. I am trying to run the model here. So if you try to run the model, it will take hours together for you to run. But this particular code is configured in such a way that one epoch will take around 5 to 6 minutes. For running this whole code, you need to start from here. You need to start from the first particular step and then you need to move towards the last particular step, which is already a run code. You can look into the code and start running the code. Anybody has any kind of a difficulty in understanding the code, a simple person who has learned machine learning should be able to understand this particular Python code, which is a very normal and a basic code for Word. Anybody has any difficulties? Tokenization, remember, optimizers, model.compile, summary and evaluation of the model, that is model.fit, where you are giving the epochs and you are giving all the other values of batch size, which are hyperparameters to tune. So this is a simple word-based code. Just given another example based on word, where I am trying to convert an English sentence to the Spanish. Okay, so you can see here it is called neural machine translation, which is used in almost all the phone applications. How to translate a particular input, which is in terms of one language to another language. So, understanding the basics of tokenization, I don't think this is very difficult for you to understand. You need to take a BERT model where you are trying to use it as a bidirectional model. Tell me in a very simple term, what did you understand by bidirectional? What do you mean by bidirectional? Yes? What do you mean by bidirectional? It's very simple. It is left to right and right to left. How to read the data from left to right and right to left? Why do you think it is very important for the model to read from right to left? Why can't it be unidirectional model? Yes, we can use a unidirectional model which can translate. I'm talking about neural machine translation. Even RNN can do a language translation task. In that, we use always bidirectional RNN. We will not use unidirectional RNN. Okay? For a very simple task, like just to convert one language to another language, we need bidirectional. Why is it? Why do you think it is bidirectional task? That's why you need to learn about semantic similarity, which is very important. What do you mean by semantic similarity? The sentence which has a particular word, when I read from right to left, will not make any sense when I read from left to right. So that's why a collab file dedicated to semantic similarity is being given here, particularly for you to understand sentence level translation. Okay? So before coming to machine translation, try with sentence similarity. Words which are very similar, what is the semantic meaning? Try to understand that. That will give you a very good answer for why is it bidirectional model and why should we consider it for machine translation task. Correct? Again, in a machine translation task, do you think we use only encoder architecture? I'm just moving forward in a very simple way. Do you think we use only encoder architecture? Machine translation, Kannada to English, English to Kannada, or English to Spanish, Spanish to English. Do you think we need both encoder and decoder in that context, or we need only encoder in that context? We need both there because we are trying to encode one particular data and decode the meaning out of it. Correct? It's a neural machine translation. That's why we need both encoder and decoder when it comes to this particular architecture. That's why neural machine translation is a task of a transformer. BERT will help you to actually convert the data or a word or a character in a particular sequence. So transformer, we do need a decoder here because I converted the text into one particular language, what if I have to get it back and try to understand the meaning? So I'm using encoder and decoder both. This whole particular architecture is both of an encoder and decoder architecture. I'll quickly go through, take all the libraries, take this particular data set for English to Spanish, okay, pass the data set, open the file and then convert it into tokenized data. You will get something like this with the start token and the end token. I'm trying to train the data set, or which is already a pre-trained model, which is which foreign language are you learning. I already have the translated output here. Correct, no? So this data I'm trying to take and I'm trying to create a text pairs. Okay? So how many are the total trainable parameters and how many are the validation parameters, test parameters I have mentioned here. Vectorizing the data. What do you mean by vectorizing the data? It is assigning the numerical values for whatever the words that you are trying to take. Okay? So basically when it comes to any kind of a neural vision translation, even the Kargunita, you know what is Kargunita in Kannada? What do you mean by Kargunita? You need to even understand all the intricate details of a language, a, I, e, ka, ka. Like that, the whole Kargunita of the language has to be understood. It is in detail how exactly the language works, right? When it is K, if you give KA, there is a different meaning, right? So understanding that is very important. So in such a case, I will give one kind of a vocabulary which fits for the particular data, which is of the size maybe 15,000. I will use all kind of Kargunita. I will give vocabulary size of 15,000. And then sequence length as 20 and batch size as 64. You can vary the batch size. Can I give a batch size of 3? Can I give a batch size of 3, 5, 8? Among 3, 5, 8, can you tell me which is a correct batch size and which is a wrong batch size? Yes? 8 is the correct batch size. Why do you think 8 is the correct batch size? Very, very, very simple thing you need to understand that it is in terms of 2 power. Yeah. Batch size will come in terms of 2 power. It is 2 power 0 means batch size 1. 2 power 1 means batch size 2. 2 power 2 means batch size 4. Very important, it is 2 power. We cannot use it as 3, 5, 8, 3, 5, 7 or 9. It should be 2 power. That's how the neural network model will get converged. Okay? So batch size is 64. I'm trying to vectorize and tokenize whatever the data that I'm given. If it is in a well-structured format in terms of data, I will encode and decode the data. I will take the English data as input and I will decode it to SPA, Spanish data. Okay? So you can see here, target shape is 64, 20. Can you tell me? Why do you think target shape is 64, 20? What is that 64, 20? 64 is a batch size. What is 20? You can see here, sequence length plays a very, very important role when it comes to machine translation. Maximum sequence length has to be given. So that's why a decoder with this length given, it should not exceed or it should not misinterpret the data. So that's why we give it as a maximum sequence length to handle for training the data. So 64, 20 will be the encoded input and it will be the decoder. So the shape of it is batch size and the maximum sequence length, and the target shape also has to be 64 and 20, the same. Building the model is a transformer encoder decoder architecture with embeddings, dense layers and multi-head attention. How many people have heard of multi-head attention here? Multi-head attention. When we know about attention, there is something called multi-head attention. That is, whenever we discuss about attention mechanism, what kind of complexity it can handle. Multi-head attention will come down to quadratic complexity. Okay? So there are different kinds of complexity. Everything is da. We cannot avoid da. We cannot live without da. We need to understand that what exactly is that. Omega or theta, what do we use? In deep learning, omega or theta, what do we use? There are different asymptotic notations, right? Omega, do we use omega or theta? Or big O? Maybe you should be able to figure out that when you run this code now. Okay? So what is the complexity you need to figure out? Multi-head attention is quadratic complexity. Nowadays there are many kind of attention model which will come down to linear complexity. So moving from one attention differentiation to another attention, let's say like a performer reformer attentions, will talk about linear complexity. It will not talk about quadratic complexity. Quadratic complexity will introduce a lot of overhead in future. So that's why there is a difference between different attention mechanism. Okay? I have a dense layer. One dense layer and activation function used is ReLU. Again, importance of activation function. Do you know why do we use ReLU activation function? Can you tell me when it comes to a binary classifier, what kind of an activation function can I use? Binary classifier. What kind of, yes? It's not. It's activation function. The binary classifier. Do you know what is the output of a binary classifier? Do you think when it is a dog and cat, what will be the binary classifier? It will give me both dog and cat because it's binary? No. It will give me only one output, that is whether it's a dog or cat. If I want the probability of dog and cat in that image, it's looking like both dog and cat. I need to go for softmax, which is a probabilistic activation function, or else, if at all I go for multi-class, as I said, I want probability, I can use something called ReLU activation function, leaky ReLU, which are very good at convergence. Okay? So that's why this is very important, activation function. I'm using one layer and two layer. What do you mean by batch normalization? I hope people are noting down. All these are very important. Batch normalization. What do you mean by batch normalization? Do you know that when you are trying to train the data, there is only one particular batch that is not performing well? So, normalizing the data batch by batch plays a very important role. So that's why we go for batch normalization, batch by batches. That's why I give batch size as 64. Or else, can I train the whole 1 million labels and the data that are available in the dataset all at once? No. I cannot do that. I need to give it in terms of a batches. Slowly the model has to converge, gradients has to converge. So that I am trying to give. And then a padding mask. What do you mean by padding mask? In terms of a neural machine translation, the positional encodings are the mask. In what position does the data comes or a text comes? That's why positional encoding plays a very important role. So finally, we have even a function for positional encoding, letter by letter, word by word, based on the vocabulary size, we give the positional encodings. One hot encoding is a technique which will help you for encoding the data. That is, I am assistant professor. I will be 001, am will be 0100. You know this in terms of networks, right? Where the grid comes into picture. So neural machine translation is also same. But which position what is coming. So after After that, we have decoder architecture here. Whatever the data encoded, I am trying to decode it. So I have same particular information or the parameters that are used as layers activation function in encoder will be used in the decoder. Okay. So next, an attention mechanism used here is the get casual attention mask, which is a simple attention mechanism which will introduce a quadratic complexity, because I already mentioned this particular code will give you multi-head attention or a quadratic complexity mask. Okay. Maybe in detail for you to understand, it's very difficult now. Once I give this code, you can experiment on one simple code and understand each line. Then you will get a clear picture of it. Okay. So encoding dimension is 256, latent dimension is 2048, and attention height is 8. This is very main for any transformer architecture. What do you mean by embedding dimension? Can you tell me why have I given 256? Why is it not 256 cross 256? Any kind of a neural network architecture, if you observe, it will be 256, 256. Why is it only 256? Yeah. What the dimension is the text data. Text data. What the dimension is text data? Text data is 3 dimension. Do you agree with me? Do you agree text dimension is 3D? Yeah? Is it true? No, right? No. Text dimension is only 1D. Image has height and width, so it is 256, 256. Image is 2D. What is 3D? A video data will be 3rd dimension, which is height, width with a depth. 3 dimension volumetric data. I can have even 4th dimension. What is a 4th dimension type? Only 1 dimension. Let's give 256. That's a very simple understanding when it comes to text data. Latent dimension is 2048. While computation, if I give only 256, it will not stop, because it can expand the layers and it can go to any dimension, because feature matrix is not 256. Multiply, it will go to higher dimension. So let's design it as 2048. Attention heads is 8. Multi-head attention with the 8 values, or maybe the sequence with 8, I can have multi-head attention. So based on that, this is the whole architecture: encoding layer, positional embedding, output layer, and the model. So like that, how many do I have? One encoder and a decoder I have, which is an input of the encoder I need to take, then only I can decode. So the input for the decoder is the encoder output. So that's been given here, and I will take transformer keras.model in which I have both encoder and decoder. It will look like this. The transformer architecture will look like this: encoder input, positional embeddings, decoder, transformer encoder, and the functional layer. So trainable parameters are 19 million parameters are there here. So I will try to decode the sequence. For that I have start token and the end token. Based on the 30 epochs, my output will look like this. She handed him the money. This is Spanish. I will not read, you can read it by yourself. So English import taken as a Spanish. People who want to understand about similarity, which is again a very little details, you can go through this. So we learned about bird, right? So last particular topic, GANs. Okay. So what is your understanding related to GANs? Generative AI is something which is dealing with GANs. A very simple example I have given here related to conditional GANs, which is a type of a GAN. Do you know what is a GAN? On a very simple note, it has two particular components, which is a generator and a discriminator. So can you tell me what do you mean by discriminator? Have you heard anywhere what is discriminator? How many people here are aware about machine learning in detail? Or maybe about machine learning? Okay. Sir is aware. Okay. So I will not waste time. I will give you the answer. Discriminator is used in all the classification models. Discriminator is a function. What is y is equal to mx plus c, which is a straight line. Where do we use that? In a logistic regression, right? So, what is this? Am I talking about regressor or a classifier? Do you think both are same? Regressor and classifier? Both are different, right? So, I can use a straight line to differentiate the data or class labels, which is a normal logistic regression or a kind of a regressor based approach. When do you think straight line will not give any kind of a result? Why do you think straight line is not very important to classify the data? Yeah. Tell me something, straight line is used for linear classification. What do you mean by non-linear data? Do you know what is non-linear data? I cannot classify the data with straight line. It's called a non-linear data. That's why this whole big concept of deep learning came into picture, where I can classify the data with activation functions which will introduce non-linearity. Correct, no? In terms of different shapes. Correct? Ellipse shape or maybe in a shape which is not linear at all. That's why to introduce non-linearity, we have deep learning. No big difference between machine learning and deep learning except non-linearity, or else logistic regression will solve all kind of a problem. Okay? So talking about GANs, I am trying to generate a data which is a new data. Okay, I want to generate a data of myself, which is a new data which will look like me, which we have already done in every AI app will give a very best version of my image. Correct? Why do I think it is giving me the best version of my image? It's looking like me with utmost clarity, very beautiful and everything. Why is it giving like that? Because whenever a generator is trying to generate a data, discriminator will fake it in such a way that generated data is the original data. That is the whole concept of GANs. I generated the data. How to fake that generated data as the original data, just like me, is something which is Gen AI or a GANs can do, generator and a discriminator. Now, putting a conditional on generate like this, generate with my cheeks as pink roses, putting a condition will be an example for a conditional GAN. I put a condition on generating the data. So that's why I have a condition as an extra factor when it comes to condition GANs. Again, I am trying to use an example of minced handwritten digit. How to fake the handwritten digit data. This is the last concept. So you can see here, same, it is an architecture with generator and discriminator. Different batch size, dimension and number of classes has been given. 10 different classes when it comes to minced data set. I am trying to divide the data into training and testing sample. I can actually create the training and testing sample and I can show the number of parameters in this particular dimension. Since it's an image, it will be in 2D, 2 dimension. If it is grayscale image, color image, you will know 1 channel and 3 channel, right? So discriminator, a code is there which is a normal deep learning code. Generator also a code is there which is a normal deep learning code with a number of layers. Convolution layer is being used here. So creating a conditional GANs with generator and discriminator, you have all the different metrics and training steps that are designed here. one hot encoding is done because there might be a condition where categorical data has to be converted into numerical data. So for this, the whole code has been given here for you. So this is the main training with the number of epochs. Give the optimizer, it will help you to train the conditional GANs. Based on that, you give what data you want it to give you the output as, what particular class it falls to. This is all about BERT model and GANs model, basic for you to understand what will come in future in next 5 days. Okay? Thank you.
Thank you, madam, for a wonderful session. Now we have a hands-on session, whatever madam has taught till now. So practically you have to implement and you have to explore. So I would like to thank Jamuna S. Murthy madam for delivering such a wonderful talk and demonstrating the lab session. Thank you, madam. So I request you to kindly accept this moment as a token of our gratitude. Now we move to lab, CSC lab 009. So all of you please move to CSC lab 009 in first floor.
ನಾಳೆಯಿಂದ ಅದರಲ್ಲಿ ರೋಲ್ ಮಾಡಿದ್ದು ಡಿಸ್ಪ್ಲೇ ಮಾಡ್ತೀನಿ, ಇದರಲ್ಲಿ ರೆಕಾರ್ಡ್ ಮಾಡ್ತೀನಿ. ಎರಡು ಇದ್ರೆ ಕರೆಕ್ಟ್. ಮಾಡಿ ಮುಗಿಸ್ಬಿಟ್ರಲ್ಲ.
ಒಂದು ಬಸ್ ಇಡ್ಸಾರೆ ಒಂದು ಬಸ್ ಇಡ್ಸಿದ್ದಾರೆ
ಎಲ್ಲ ಬಸ್ ಇರುತ್ತೆ
ಎಲ್ಲ ಬಸ್ ಯಾರು ಹೋಗಲ್ಲ ಅಂತ
ಬನ್ನಿ ಇಲ್ಲಿ ನೇತ್ರ ಇಲ್ಲದ್ರು ರಜಾರ
ವಾಟರ್ ನೀರು ತಗೊಂಡು ಕುಡಿದ್ಬಿಟ್ಟು
ಬೈತಾರ ಮೇಡಮ್
ಮೇಡಮ್ ಅವರು ಹುಡುಗಿದ್ದಾರೆ
ಮೇಡಮ್ ಅಲ್ಲಿ ಬಾಟ್ಲಿ ಇರ್ಬೇಕು ಇಟ್ಕೊಳ್ಳಿ ಕ್ಯಾನ್ ಇದೆ ನೋಡಿ ಮೇಡಮ್ ಅದದ್ದು ನೇತ್ರ ಇದ್ರೆ ಕರೀರಿ ನೇತ್ರ ಕರೀರಿ ಇವು ಕಳಿಸ್ಬೇಕಂತ ಮೇಡಮ್ ಹೇಳಿದ್ರು ಈಗ ನೀವು ಇಟ್ಟಿರಲ್ಲ ನೇತ್ರ ಇದ್ರೆ ಕಳಿಸಿ ಅಂದರು
ಅಕ್ಕಿ ಸ್ಕೋರ್ ಸರ್ ಇವಾಗ ತಾನೆ ಜಸ್ಟ್ ಇಲ್ಲೇ ಒಂದು
ನೇತ್ರನ ನೇತ್ರ ಹತ್ರ ಕಳಿಸಿ ಅವ್ನ ಅಂದರು ಇನ್ನೇನು ಮಾಡೋದು ನೋಡ್ರೆ ಸ್ಕೋರ್ ಕಳಿಸಿ ಅಷ್ಟೇ